So we'll talk about the remaining types of wood products here. And we're not going to do a lot of design problems on this one. I'm just going to talk to you about where to find the information, and it actually follows what we've already done as far as examples. So, engineered wood products. One of the things you'll see delivered to site already prefabricated is trusses. So whether those are floor trusses or roof trusses, this is pretty common even in residential construction to have these prefabricated. It saves a lot of time. So these are built in the factory. You can see that they're basically 2x4s or 2x6s, and they're connected with these kind of toothed fasteners. So you can see these at a lumber yard anytime or out on site, which is an effective and efficient way to do this. And you order these things based on span, what the loads are. So it's kind of like ordering them out of a catalog. Your slope or your pitch, this would be for the roof ones. And if there's any overhang, right? So structurally it looks a little bit different. Particularly on roofs, that's going to be that overhanging piece. Okay, so you order them to match whatever your need is, and they are prefabricated to meet that load. Similarly, looks like I'd already written on this one. Similarly, you can get I-beams or I-joists, as they're called, also used for floors or roof systems. They can be anywhere from about 9.5 inches deep to almost 2 feet deep, and you can get a pretty substantial length out of these, so 40 plus feet, which is way beyond the span that we can typically do with our sawn lumber, more on the order of what we get with the glulams. So the top and bottom are where your extreme fiber stresses are, and those guys are lumber or laminated lumber, sawn lumber. And then the web here, that's the part that is a lower grade. So it's a OSB, oriented strand board, or plywood, right? So we have this I shape, but you can see the top and bottom are your lumber, and then in here is kind of the OSB or plywood, and that makes our composite. And similar to glulams, we want to put the highest quality lumber on the two extreme fibers. So if we go into the NDS, Chapter 7 has the I-joists, the prefab wood I-joists. These are used very commonly in residential construction and light commercial, if you've got wood framing. It tells you what they are in 7.1.2, and then you have some reference design values mentioned here, but where you actually get them is from the manufacturer's literature, because each manufacturer is going to have their own type, and so they'll provide you with the information that you would usually look up in the tables. In the case of I-joist, it's done a little bit differently, so instead of looking at the stress F, we will look at things like what's our required bending moment, shear, etc. Okay, so if I go into Chapter 7, we still use adjustment factors, and those are right here. So in Table 7.3.1, for instance, in flexure, you're going to have 5 adjustment factors, and it lets you know what those are. You've worked with these quite a bit now with sawn lumber and glulams. Instead of doing stresses, however, we're going to look at a demand moment and then our adjusted design value, design moment. Otherwise, everything is the same. So instead of big F and little f, you're using the M's for moment. Likewise for shear. Now, for these guys, you don't use D away from the face. You use the shear right at the center line of the support instead of out a certain distance. So this is what we've basically been doing in the examples anyway, because shear hasn't been the controlling factor. But in this case, you can't, if the shear is not meeting, you can't just go out a distance D and see if it meets there. Likewise, deflection, they'll provide you information on deflections in the literature from the manufacturer. So you'll know where you're getting the joist from, and that's how you decide. You get their literature, and that's the properties that they're telling you those components have. So why would I use trusses or I-beams? The big one is labor savings. So installation savings, which is the installation savings is primarily due to labor savings. And as labor costs more and is in shorter supply, that starts to make prefab type components even more and more favorable from a cost perspective. So these things are already used very, very widely, but as labor keeps going up in price and it becomes more scarce, we're going to see even more of this as far as a good cost option. These things have increased dimensional stability over just a board, for instance, that could warp. These things are put together as a composite in a controlled environment and laid up in an exact shape, and they're pretty dimensionally stable. I have an increased span capacity over my traditional sawn lumber. Similar to glulam's, we have the increased span capacity. It's very efficient use of the material because I'm using only the super high quality material at the edges where I need it and use a lesser quality material in the web, because shear is typically not controlling. And then finally, they're lighter weight per square foot of use. Okay, so less material use. So these are the benefits of using these guys. All right, along the same vein, there's some other types of structural composite lumber. We mentioned these at the start of class. LVLs, PSLs, and LSLs. All of these are basically wood fibers aligned along the long ways on the beam or the member. The laminated veneer veneers or sheets are little veneer sheets with the fiber oriented along the length. Parallel strand is kind of almost a larger chunks of wood strand along the length, and then the laminated strand is kind of a combination of the two, where we've got strands oriented but kind of in layers. So let me show you a picture here of what these look like. And we looked at this a little bit at the beginning of class. So here's our laminated veneers. Okay, parallel strand and laminate, so you can see kind of the layers in the laminated strand lumber, and then you see these big kind of chunks of lumber strands in the parallel strand lumber as kind of one block. And we've talked about OSB, fiberboard, particle board. Those aren't really structural things. OSB is used in the webs, and then plywood. All right. All right, so structural composite lumber is in Chapter 8 of the NDS, and these are fairly short chapters simply because they don't have all the tables and things associated with them. Same basic format as we've done for all the other wood design. There's not a lot in the NDS in this section because these are going to depend very much on the product that the manufacturer makes. So again, you're going to go to the manufacturer's literature and directly from there get the property values you need. The difference is this is, instead of what we had just for the joists or the I-joists, these guys are designed exactly like the glulam and sawn lumber, looking at stresses. You've got adjustment factors again. All those adjustment factor information that you need is in Chapter 8. Okay, and it has all the details here. So same exact process. You will just get the values, you know, your actual availability of strength, your actual strength of the type of member from the manufacturer. All right, a couple slides here. I'm just going to go ahead and talk about tension members. This is not a popular use of wood other than in some specific scenarios, right? So I'm not using, you know, it's not like a cable, right? We're using these primarily in flexure. We will use them somewhat in wall design. floor design or diaphragms, but not in direct tension. But we will have tension as part of another member. So if I had a truss, the bottom cord would be in tension. End members of shear walls. So if I have a shear wall and I have these ends, and we'll look at this, as this lateral force comes over, this wall is going to want to go this way, right? And that will give me tension on one side. Collectors and diaphragms, we'll talk about this also with shear walls. Tension is, as always, P over A, right? So it's the same process except for our stress is not bending stress, so it's not the My over I stress, it's now the P over A stress. So in pre-stress, it's that first term where we combine all those together. Sorry, I keep referring to pre-stress, but some of you had me in that class, and obviously I teach that one more than this one. But basically, this is just your pure tension or pure compression as P over A. Okay. Otherwise, it's going to be the same basic process. You have to remember, if I have holes or something else that reduces the cross-sectional area, I can only use the net or the part that doesn't have the hole, right? So if I'm looking on the side and I've got two holes all the way through the piece of wood, if I cut through here, I see that I've got this, right? Here's the wood, and there's a section piece missing there. I can only use that net, so the gross minus so full section minus the whole area, right? Typically, the bolt holes will be cut about a 1/16 larger than the bolts that will be used inside of the holes. You're required to have at least a 32nd, but if you've been out trying to bolt stuff together, it's nice to have a little bit more play than that, and that's typically what you'll see. At the same time, you don't want them so loose that the bolts wiggle around a lot or that we lose more cross-sectional area than we need to. And just kind of to put this all together for sawn lumber, in tension, so our stress is the P over A, but it's the same basic formula, except for you're going to look at stress values for tension and go straight back into 4A or 4D. So we're back into sawn lumber now, not composite lumber, and the adjustment factors are similar. Okay, so straightforward, tension's just P over A instead of the My over I. All right, we will stop here on this one, and then we are going to go ahead and pick up with compression members.